Hey guys, welcome to the video series on syllabus point N1.2 on geometrical representations of a complex number. So yeah, if you want a set of these notes to copy down and follow along, you can just download them on your Moodle site. But yeah, so we'll begin. So the first thing we'll look at is the Argand diagram. So pretty much this is just the complex plane. So when we're graphing, um, we know a complex number x plus iy. That's pretty much our ordered pair for us. So the real bit is the x and the imaginary bit is our y. So yeah, so on the complex plane as well, as I said, the x-axis is your real axis, and the imaginary axis is pretty much your y-axis. So just say this point here, z equals x plus iy. So you can see the distance there across, that's your x, the real bit, and then the height up is your y value. So that point P there is xy. So yeah, so just say if we had the example 3 minus 2i, the real bit is x value. So that point would be 3, negative 2. Also, just say if we had the point z equals root 3i plus 2. So remember, it doesn't matter what order it's written in. The imaginary bit's the y and the real bit's the x. So this coordinate would be 2 root 3. All right, so the next thing we'll look at is the modulus. So the modulus is pretty much the distance OP here. So the modulus, it's written, it looks similar to the absolute value signs. So that just means the modulus of z. So pretty much it's just, as we can see, because it forms a right angled triangle, it pretty much just uses Pythagoras or the distance formula to find out what z is. So if you had to ever find the modulus of a complex number, it's just square root of the real bit x squared plus the imaginary bit y squared. So important thing is don't include the I when you write the imaginary bit. So it's just y squared, it's not like yi squared. All right, so theta is the angle between the x-axis and in this case the vector OP. So the angle, pretty much when we say argument, that just means the angle of the complex number. So argz in this case would be theta. And then normally we write our angles in the principal argument, which is between negative pi and pi, or negative 180 and 180. But yeah, we'll look at them more later when we do an example. All right, so first let's just practice a few questions on finding the modulus. So if z equals 2 plus I and w equals minus 3, so minus 1 plus 3i. So pretty much we'll just write them down first. And then as the formula we saw above, it's just square root of the real bit squared and then the imaginary bit squared. So remember I is the same as 1i. So it'd be 1 squared and that'll give us root 5. So w is minus 1 plus 3i. So the conjugate of that would be minus 1 minus 3i. And then we just do the same thing if we want to find the modulus. We just square the real bit. And then we add the square of the imaginary bit. So in this case, we end up with root 10. So if we have to find the modulus of this one, so this one's a bit more involved. So first, let's write down what we know. All right, so then normally we know that when we have two complex numbers dividing each other, we have to multiply by the conjugate of the denominator so that we can simplify it. So in this case, minus 1 minus 3i. And then, yeah, so just simplify it first. And the bottom is difference of two squares. That's 1 minus 9i squared. So simplify the top. So put real and imaginary bits together. And then the bottom becomes 10 because I squared equals negative 1. And then that gives us, so yes, this can be written as a whole fraction. So 1 minus 7i over 10, or if you separate it, it's 1 over 10 minus 7 over 10i. So we just do the same thing just square the real bit and then square the imaginary bit. And that would give us root 50 over 100, which equals 1 on root 2. And then if you want to simplify that further, it'll be root 2 over 2. So yeah, so it can be shown that any complex number can be written in the form r cos theta plus r sine theta, where r is the modulus, which we just practiced just then, and theta is the angle, arg z. So yeah, so mod arg form is pretty much r cis theta or r cos theta plus r sine theta. So r cis theta is just a short way, and then the standard form is what we've been doing earlier. So x plus iy or like a plus ib, doesn't really matter which way we put it. So next time we'll go over how to put it in mod arg form fully.